The 20th century was a golden era of science, where brilliant minds reshaped humanity's understanding of the universe and itself. Among them, Albert Einstein, born on March 14, 1879, in Ulm, Kingdom of Württemberg, Germany, stands out as a beacon of theoretical physics. With his special theory of relativity, 1905, he introduced the concept that space and time are not absolute, and with his general theory of relativity, 1915, he explained gravity as the curvature of space-time. His iconic formula, EmC2, elucidated the relationship between energy and mass, revolutionizing modern physics. Einstein received the 1921 Nobel Prize in Physics for his explanation of the photoelectric effect, proving that light consists of photons, laying the groundwork for quantum mechanics. He also contributed to the theory of Brownian motion, explaining the random movement of particles in fluids, and to quantum statistics, influencing statistical physics. In 1933, as the Nazi regime rose to power, Einstein fled Germany to escape persecution, settling in Princeton, USA, where he taught at the Institute for Advanced Study. A humanitarian, he actively supported peace, democracy, and human rights, but stirred controversy by urging President Roosevelt to develop the atomic bomb, only to later oppose its use in war. His disheveled silver hair, eccentric personality, and independent thinking made him a cultural icon, appearing in books, films, and global imagination. In his later years, Einstein pursued a unified field theory to combine gravity and electromagnetism, though without success. Passing away on April 18, 1955, Einstein left an enduring legacy, from astrophysics to the philosophy of science, inspiring generations of scientists to explore the mysteries of the universe. His work not only shaped science, but also transformed how humanity perceives reality, enabling advancements like GPS and nuclear energy. While Einstein illuminated the cosmos, Marie Curie, born on November 7, 1867, in Warsaw, Poland, pioneered the study of radioactivity, ushering in a new era for science and medicine. The first woman to win 2 Nobel Prizes, Physics 1903 with Pierre Curie and Henri Becquerel, Chemistry 1911, she discovered polonium and radium, laying the foundation for nuclear physics and cancer treatment. Born into an intellectual but impoverished family, Curie overcame hardships to pursue education in Paris, where she met Pierre, her husband and collaborator. Her work on X-rays not only advanced understanding of radioactivity, but also revolutionized medicine with applications like X-ray imaging. During World War I, Curie drove ambulances equipped with X-ray machines, saving thousands of soldiers by aiding rapid diagnosis. Facing gender bias in a male-dominated scientific community, she persevered in rudimentary conditions at the University of Sorbonne, becoming its first female professor. She died in 1934 from leukemia, likely due to prolonged exposure to radiation, in unprotected experiments. The Curie Institute, which she founded, remains a leading center for medical research, continuing her pioneering work on cancer. Curie's dedication, courage, and humility not only paved the way for gender equality in science, but also inspired women worldwide to pursue research careers. Her legacy profoundly impacts physics, medicine, and society, from modern cancer treatments to the recognition of women's roles in STEM. From radioactivity, the scientific journey leads to the atomic realm with Niels Bohr, born on October 7, 1885, in Copenhagen, Denmark. His atomic model, depicting electrons orbiting the nucleus, was a landmark in physics, laying the foundation for quantum mechanics. Awarded the 1922 Nobel Prize in Physics, Bohr developed the principle of complementarity, clarifying the wave-particle duality of matter. elucidating complex quantum phenomena. Born into an academic family, Bohr studied at the University of Copenhagen and worked with scientists like J.J. Thomson and Ernest Rutherford before developing his namesake model. During World War II, he contributed to the Manhattan Project, aiding atomic bomb research, but later advocated for nuclear peace, calling for international arms control. He founded the Niels Bohr Institute, a leading physics research center that attracted brilliant minds like Werner Heisenberg. Bohr's famous debates with Einstein on the nature of quantum mechanics, particularly its randomness, cemented his central role in 20th century science. His open-mindedness, profound thinking, and collaborative spirit made him a pivotal figure. Passing away on November 18, 1962, Bohr's legacy extends beyond atomic theory, shaping scientific thought from quantum research to technologies like microchips and lasers. His institute remains a global research hub, and his ideas continue to influence modern physics and the philosophy of science. While Bohr explored the microscopic world, Alan Turing, born on June 23, 1912, in London, England, laid the foundation for the digital age. Regarded as the father of artificial intelligence and computer science, Turing developed the Turing machine, a theoretical model that defined modern computing. During World War II, he worked at Bletchley Park, breaking Germany's Enigma code, significantly contributing to the Allied victory by decoding critical military information. His Turing test proposed to assess a machine's ability to mimic human intelligence, foreshadowed the future of AI. Born into a middle-class family, Turing studied at Cambridge and Princeton, where he developed his groundbreaking ideas on computation. Tragically, his life was marred by persecution for homosexuality, then illegal in Britain, leading to his death in 1954, possibly by suicide, leaving unanswered questions about his passing. In 2013, Queen Elizabeth II granted him a posthumous pardon, recognizing his monumental contributions. Turing's work profoundly impacted personal computers, artificial intelligence, and cryptography, from modern algorithms to advanced AI systems. His legacy transcends science, promoting societal recognition of diversity and individual rights. Turing became a symbol of innovation and courage, inspiring scientists and engineers globally while underscoring the importance of fairness in science. The scientific narrative shifts to biology with Rosalind Franklin, born on July 25, 1920, in London, England, who played a pivotal role in discovering the structure of DNA. Her X-ray diffraction image, Photo 51, taken at King's College, provided critical data for James Watson and Francis Crick's double helix model, leading to their 1962 Nobel Prize in Medicine. Though under-recognized during her lifetime, Franklin's role was later acknowledged as a turning point in molecular biology. Born into a wealthy Jewish family, she studied at Cambridge and became an expert in crystallography. She also researched viruses, such as the tobacco mosaic virus and coal, contributing to materials chemistry. In a male-dominated scientific field, Franklin faced gender bias, but persevered with meticulousness and analytical rigor. She died in 1958 from ovarian cancer, possibly due to prolonged X-ray exposure in unprotected experiments. Her legacy lies not only in her DNA discoveries, but also in inspiring gender equality in science. Her work paved the way for advances in genetics, from gene editing to treatments for hereditary diseases, and continues to drive modern medical research. Franklin became a symbol of perseverance and talent, encouraging women to pursue scientific careers and fight for deserved recognition. While Franklin unraveled the mysteries of life, Max Planck, born on April 23, 1858, in Kiel, Germany, laid the foundation for quantum mechanics. Awarded the 1918 Nobel Prize in Physics, he discovered that energy is emitted in discrete quanta, solving the black body radiation problem, a major challenge in classical physics. This work paved the way for Einstein, Bohr, and Heisenberg, shaping modern physics. Born into an academic family, Planck studied in Munich and Berlin, becoming a professor at the University of Berlin. He led the Max Planck Society, Germany's premier scientific institution, and played a key role in advancing research. During World War II, he faced pressure from the Nazi regime and lost his son in an anti-Hitler plot, enduring significant personal tragedy. Nevertheless, he upheld scientific and ethical values. Passing away on October 4, 1947, Planck's legacy profoundly influences physics, from lasers to semiconductors and applications like electronics and medicine. His humility and pioneering thinking inspired scientists, and the Max Planck Society remains a symbol of research excellence. Planck's work not only transformed science, but also ushered in a new technological era, from quantum energy to modern devices. Continuing the journey, Richard Feynman, born on May 11, 1918, in New York, USA, brought a unique perspective to theoretical physics. Awarded the 1965 Nobel Prize in Physics for his work on quantum electrodynamics, he developed the path integral formulation, simplifying complex quantum calculations. Born into a Jewish family, Feynman studied at MIT and Princeton, where he displayed early brilliance. Joining the Manhattan Project as a young scientist, he contributed to the atomic bomb's development, but later became a science communicator through his book, Surely You're Joking, Mr. Feynman, showcasing his humor and curiosity. He investigated the Challenger space shuttle disaster, using a simple experiment with a rubber O-ring to pinpoint technical failures, captivating the public. Teaching at Caltech, Feynman was renowned for making complex concepts accessible, inspiring generations. He also researched superfluid helium and particle physics, pushing scientific boundaries. His fearless and curious nature made him a scientific icon. Passing away on February 15, 1988, Feynman's legacy lies not only in physics, but also in making science approachable, inspiring experimental thinking and education. His Feynman Lectures on Physics remain a cornerstone, influencing how physics is taught and learned globally. From the quantum realm, we move to outer space with Katherine Johnson, born on August 26, 1918, in West Virginia, USA, an exceptional NASA mathematician. She calculated precise trajectories for the Apollo 11 mission, landing humans on the moon in 1969, and contributed to the Mercury and Gemini programs. As a black woman in an era of intense racial segregation, Johnson overcame societal prejudice to become a pivotal figure in aerospace. Born into a modest family, she showed mathematical talent early, graduating college at 18. Her hand-calculated trajectories, executed with remarkable accuracy, ensured astronaut safety, including for John Glenn, who requested her verification. In 2015, she received the Presidential Medal of Freedom from President Obama, recognizing her historic contributions. Working at NASA for over 30 years, Johnson's resilience, talent, and humility inspired others, passing away on February 24, 2020. Her legacy shaped the space industry and promoted gender and racial equality in STEM. Her story, told in the book and film Hidden Figures, sparked global interest in the overlooked contributions of Black women in science, encouraging young generations to pursue their passions and overcome barriers. While Johnson conquered space, Werner Heisenberg, born on December 5, 1901, in Würzburg, Germany, illuminated the microscopic world with his uncertainty principle, stating that a particle's position and momentum cannot be simultaneously determined with absolute precision. Awarded the 1932 Nobel Prize in Physics for developing matrix mechanics, he laid the foundation for quantum mechanics, transforming our understanding of matter and energy. Born into an academic family, Heisenberg studied in Munich and worked with Niels Bohr in Copenhagen, where he developed his groundbreaking ideas. During World War II, he led Germany's nuclear program, a role that sparked ethical debates due to its ties to the Nazi regime, though he claimed not to aim for a bomb. Post-war, he focused on rebuilding German science, teaching at the University of Munich, and leading the Max Planck Institute. His profound thinking, creativity, and collaboration with leading scientists made him a key figure in 20th century physics. Passing away on February 1, 1976, Heisenberg's legacy influences modern technologies like semiconductors, lasers, and medical imaging. His work not only shaped theory but also drove practical applications, from electronics to quantum energy, inspiring scientists to explore the subatomic world. The scientific narrative shifts to genetics with Barbara McClintock, born on June 16, 1902, in Hartford, USA, who pioneered the discovery of jumping genes, transposons, in maize. Initially overlooked, her work was recognized with the 1983 Nobel Prize in Medicine, marking a turning point in molecular biology by explaining genetic variation in evolution and disease. Born into a middle-class family, McClintock studied at Cornell University, where she developed a passion for plant genetics. Working independently at Cold Spring Harbor Laboratory, she used meticulous experimental methods, observing chromosomes and plant heredity with astonishing precision. As one of the few women in science at the time, she faced gender bias but persevered, rejecting societal norms to focus on research. Her work paved the way for discoveries in genetics, from cancer to antibiotic resistance. Passing away on September 2, 1992, McClintock's legacy lies not only in science, but also in her independent spirit, inspiring women and young scientists to pursue their passions. Her discoveries impact modern agriculture, improving crop strains, and medicine, deepening our understanding of genetic mechanisms and life. In the nuclear field, Enrico Fermi, born on September 29, 1901, in Rome, Italy, stood out for building the first nuclear reactor at the University of Chicago in 1942, ushering in the nuclear energy era. Awarded the 1938 Nobel Prize in Physics for neutron-induced radioactivity research, he laid the groundwork for nuclear applications in medicine and energy. Born into a middle-class family, Fermi studied in Pisa, quickly becoming a physics prodigy. Fleeing Italy in 1938 to escape the fascist regime, he settled in the USA and joined the Manhattan Project, contributing to the atomic bomb. He also researched quantum mechanics and statistical physics, with the Fermi-Dirac statistics named after him, explaining particle behavior like electrons. Teaching at the University of Chicago, Fermi inspired young physicists with his humility and sharp intellect. passing away on November 28, 1954, from stomach cancer, possibly due to radiation exposure. His legacy shapes nuclear energy, particle physics, and technologies like PET scans and nuclear power plants. His curiosity and ability to blend theory with experimentation continue to inspire scientists, advancing research in clean energy and cutting-edge technology. Medicine was transformed by Jonas Salk, born on October 28, 1914, in New York, USA, who developed the first polio vaccine in 1955, saving millions from a devastating disease. Born into a Jewish immigrant family, Salk studied at New York University and researched virology in Pittsburgh. Refusing to patent the vaccine to ensure its widespread availability, he exemplified rare humanitarianism. Founding the Salk Institute, a leading biomedical research center, he continued studying HIV and cancer, contributing to modern medicine. During the polio epidemic, his vaccine brought global hope, drastically reducing deaths and disabilities. He worked tirelessly to ensure its safety through large-scale trials, demonstrating care and responsibility. Passing away on June 23, 1995, Salk's legacy lies in preventive medicine and inspiring scientists to prioritize community welfare over personal profit. His work influences global vaccination programs, from measles to COVID-19, shaping virology and public health. Salk's humanitarian and scientific spirit remains a guiding light for future generations in medicine. In biology, Francis Crick, born on June 8, 1916, in Northampton, England, co-discovered the double helix structure of DNA with James Watson, earning the 1962 Nobel Prize in Medicine. Building on Rosalind Franklin's X-ray diffraction data, their work revolutionized molecular biology, explaining how DNA stores and transmits genetic information. Born into a middle-class family, Crick studied at Cambridge and worked at the Cavendish Laboratory, collaborating closely with Watson. After the DNA breakthrough, he explored consciousness and brain function, contributing to neuroscience with theories on how the brain processes information. Later working at the Salk Institute, Crick inspired others with his collaborative spirit and creative thinking. He relentlessly questioned the nature of life, from genetic mechanisms to human consciousness, passing away on July 28, 2004. Crick's legacy shapes genetics, biotechnology, and life research. His work enabled advances like gene editing and treatments for genetic disorders, from cancer to rare hereditary conditions. Crick's curiosity and interdisciplinary approach continue to inspire scientists to explore new frontiers in biology and medicine. Computer science soared with John von Neumann, born on December 28, 1903, in Budapest, Hungary, a multidisciplinary genius. Developing game theory, he influenced economics, military strategy, and social sciences with concepts like Nash equilibrium. He also designed the von Neumann architecture, the foundation for modern computers, shaping data storage and processing. Born into a wealthy Jewish family, von Neumann studied in Budapest, Zurich, and Berlin, displaying mathematical brilliance from a young age. Joining the Manhattan Project, he contributed to the hydrogen bomb and researched quantum physics and applied mathematics. Working at Princeton's Institute for Advanced Study, he collaborated with scientists like Einstein, showcasing his logical and versatile intellect. He also foresaw computers' future impact, from AI to scientific simulations. Passing away on February 8, 1957, from cancer. His legacy shapes computing, artificial intelligence, and computational science. His ideas influence everything from modern software to economic models and international strategies. Von Neumann's creativity and interdisciplinary connections continue to inspire scientists and engineers to explore technology's potential. The journey concludes with Linus Pauling, born on February 28, 1901 in Oregon, USA, an exceptional chemist and peace activist. Awarded the 1954 Nobel Prize in Chemistry for his research on chemical bonds, he elucidated how atoms connect in molecules, laying the foundation for molecular biology. He also received the 1962 Nobel Peace Prize for opposing nuclear testing, influencing international treaties like the Nuclear Test Ban Treaty. Born into a poor family, Pauling studied at Oregon State University and Caltech, where he developed groundbreaking ideas on protein structures like the alpha helix, paving the way for DNA and disease research. He promoted vitamin C for health, sparking debate in the medical community. Teaching at Caltech and Stanford, Pauling inspired others with his scientific and humanitarian spirit. His anti-nuclear activism led to FBI surveillance during the Cold War, yet he remained steadfast in his peace advocacy. Passing away on August 19, 1994, Pauling's legacy shapes chemistry, medicine, and global peace movements. His work influences pharmaceuticals, protein research, and social responsibility in science. Pauling's multidisciplinary spirit and commitment to humanity continue to inspire scientists to blend research with a mission to improve the world.